prothrombin time and activated partial thromboplastin time. Prothrombin time is used to determine the activity of extrinsic coagulation factors 2, 5, 7, and 10. The PT test is important in the induction and monitoring of oral anticoagulant therapy. It is an important screening test in diagnosing genetically caused deficiencies in coagulation factors of the extrinsic system. It is used to diagnose acquired deficiencies in coagulation factors and also to check the synthesis performance of liver in hepatic diseases. Activated partial thromboplastin time, that is APTT. This is used to evaluate coagulation abnormalities in the intrinsic pathway and also to detect severe functional deficiencies in factors 2, 5, 10, or fibrinogen. Sample collection, processing, storage, and transportation for coagulation studies is very important to arrive at a correct result. Collection. The blood is drawn via venipuncture. The correct technique of venipuncture is discussed in detail in the section on phlebotomy. For coagulation studies, avoid using tourniquet or apply it for less than 1 minute. In the order of sample draw, coagulation tests must come right after culture tube draw. Contamination by drawing clotting tubes before coagulation tubes should be avoided. Collection from lines previously flushed with heparin should be avoided. Sample tube. Citrate tubes, blue top, 1 part 3.2% sodium citrate solution with 9 parts venous blood is recommended. Mix the citrate solution and blood by gentle inversion. Follow the manufacturer's instructions for the number of inversions. The sodium citrate in the tubes is in the liquid form, so care must be taken that the liquid is not lost by careless handling of the tubes. Note: any microclot formation will consume the analyte you are looking for, giving spuriously prolonged results. If syringes are used, it is important that the blood is transferred to the appropriate volume of anticoagulant within 1 minute of draw, avoiding the formation of foam. Small volume syringes are recommended to avoid clotting during the collection process. Use of discard tubes. The hypothesis that discard tubes are to be used to avoid contamination with tissue thromboplastin is not validated. However, while using a winged collection set, if the coagulation tube is the first tube drawn, use a discard tube first. This will ensure the appropriate volume in the PT tube, eliminating the dead space of the winged collection set in the discard tube. The discard tube must be a non-additive tube.
Needle gauge. A 19 to 21 gauge needle is recommended by CLSI to avoid hemolysis. 25 gauge or smaller may induce hemolysis or activate the platelets, leading to erroneous results. This is very much more of a requirement while using winged sets due to their longer path between the vein and the anticoagulant.
All reagents and test samples shall be incubated at 37 degrees Celsius immediately prior to testing to ensure reaction temperature. Water baths must be temperature controlled. Timers shall be checked for accuracy at least annually. Carefully examine the sample for clots by gentle inversion and observation. Preparation of platelet-poor plasma, that is PPP.
To obtain a plasma sample, centrifuge the blood specimen at 1500 G to 2000 G, that is approximately 4000 rpm, for 15 minutes at room temperature, to achieve a platelet count of less than 10,000 per microliter. This is as per NABL Standard 112.
The counts must be verified on randomly selected specimens once in 6 months or following a major repair on the centrifuge which requires recalibration. Use a swing-out bucket rotor to minimize the contamination of the plasma with platelets and other blood cells. Double centrifugation of the sample may be performed to ensure that the sample is platelet poor. This can be achieved by transferring the plasma following the initial centrifugation process to a non-activating plastic centrifuge tube using a plastic pipette, then centrifuging the sample for an additional 10 minutes.
Note: while transferring the plasma from the primary tube, separate the PPP without disturbing the buffy coat. And when aliquoting to a secondary tube, take care to not include the residual platelets that may have collected at the bottom of the centrifuge tube.
The presence of visible hemolysis, as evidenced by a pink to red tinge to the plasma, should be noted. Lysis of red blood cells and the resultant release of intracellular or membrane components may cause clotting factor activation. This activation of coagulation factors may impact clotting time results, whether using an optical or mechanical endpoint detection.
Short-term storage of plasma for coagulation testing. Coagulation tests must be performed within 4 hours of collection. If longer delay is expected, plasma should be made platelet-free and kept frozen until the test can be performed. That is, at minus 20 degrees centigrade for up to 1 week and at minus 80 degrees centigrade for up to 1 year.
For the whole blood samples maintained at room temperature, avoid mechanical agitation during the storage that may cause spurious elevation of the PT or INR through an unknown mechanism. Sample integrity is maintained at room temperature if samples are centrifuged immediately after blood collection. Storage at refrigerated temperature 2 degrees Celsius to 8 degrees Celsius is not recommended, as it may result in cold activation of factor 7 and therefore alter the PT results. Specimens for routine APTT assays from non-heparinized patients can be maintained uncentrifuged with plasma remaining on the top of the cells in an unopened tube kept at room temperature for up to 4 hours from time of specimen collection.
Placing whole blood specimens directly on ice or in an ice water bath simulates refrigeration and is also not recommended.
Quality controlled. A control, normal and abnormal, should be tested with each batch. Each control must be used according to the manufacturer's directions. Control values and limits will vary with the brand used. Calibration. The centrifuge used for PPP should be calibrated annually. The pipettes need calibration annually. The water bath used for manual methods should be calibrated annually. Ideally, multiple areas of the water bath should be calibrated for the operating temperature. The timer should be calibrated every year. In automated methods, temperature, timer, and optical, mechanical, or other mechanism of testing should be calibrated. ISI, INR, and MNPT are 3 numbers that are very important in the standardization of PT results. This is because the thromboplastin reagent used for PT estimation is very variable in its strength. PT is a test that needs continuity. A patient on anticoagulants will need repeated estimations of PT. So, the variability within the same lab and between labs has to be minimized. What is an ideal thromboplastin? It will be the same as the standard PT reagent established by WHO. Since in real practice this is not possible, 2 corrective steps are undertaken. 1. Each batch of thromboplastin reagent is calibrated against the standard PT reagent established by the WHO, and this value is called the ISI or the International Sensitivity Index. The ISI value has to be assigned by the manufacturer for each lot of reagent. The lower the ISI, the more sensitive the reagent. ISI value of 1.8 to 2.4 has low sensitivity. ISI value of 1.4 to 1.8 will have average sensitivity. An ISI 1.0 to 1.4 will have high sensitivity. Always understand the ISI value whenever you get a new lot of PT reagent. Search for the ISI value on the kit insert. For the kit used in this demonstration, the value is 1.6. Some kits can specify multiple ISI values. This is because the reagent needs to be calibrated for different equipments. 2. INR or International Normalized Ratio. Every lot of thromboplastin is also required to have a population mean derived from the normal population. For this, an estimation of MNPT or mean normal prothrombin time is required. A laboratory can estimate the MNPT from a minimum of 20 healthy individuals with a relatively equal mix of both sexes over a range of age groups. People on anticoagulants, pregnant women, people with known bleeding tendencies should be avoided. Estimation of a geometric mean is to be preferred to the arithmetic mean. MNPT samples must be fresh. The mean of a laboratory normal control is not an acceptable substitute for the MNPT since control samples may differ excessively from each other, particularly in the case of less responsive reagents. The MNPT should be determined with each new lot of PT reagents.
Calculation. It is advisable to have a software like Excel to make the calculations easier. Say, 20 samples are run in duplicate. The mean of both runs for each sample is calculated. Calculate the percent difference between the two readings. The percent difference should be less than 10. Exclude all the outliers that have a percent difference more than 10. In our example, one set of values shows 12.5% difference. Exclude this one. Then, the geometric mean of all the 19 accepted mean values can be calculated by inserting a simple formula on your Excel sheet. In our example, it comes out to be 11.25 seconds. Now, calculate the standard deviation on the 19 sets of means by inserting a simple formula on your Excel. Standard deviation in our example is 1.51. Geometric mean plus 2SD and geometric mean minus 2SD will give you the upper and the lower limits or the range between which the values should lie. Hence, the upper limit is 14.27 seconds and the lower limit is 8.23 seconds. Now, look through all the mean values to see if any exceed the specified limits. Exclude all these outliers. That is, any value that does not lie within this range. In our example, these values are 16.45 and 8.15. 16.45 is greater than 14.27 and 8.15 is lesser than 8.23. Calculate the new geometric mean with the inliers. It comes out to be 11.22 and this is mean normal prothrombin time for this lot of thromboplastin. As is evident, the MNPT has been changed from 11.25 as in the previous calculation to 11.22 now. Since the standard deviation has also changed, the ranges also change accordingly. This final range, 12.32 to 10.12, will serve as the biological reference range for this lot of thromboplastin. The biological reference ranges stated in the literature are generally between 10 to 12 seconds for human thromboplastin and 11 to 16 seconds for rabbit thromboplastin. However, this cannot be used for patient reporting. Every lab is required to calculate the MNPT and the biological reference interval or range as per this above method. Once the MNPT is known, INR can be calculated by this formula. INR is equal to patient's value by MNPT value raised to the power of the ISI value. This INR value should be reported every time for each patient.
Now let's learn about the procedure of PT. PT. The test should be performed in a well-lit room to observe the clot formation. Equipment. 1. Water bath maintained at a temperature of 37 degrees Celsius plus or minus zero point 0.5 degrees Celsius. 2. Stopwatches. 3. Automated pipettes, either fixed or variable volume, capable of delivering zero point 0.1 ml and zero point 0.2 ml accurately and precisely. Pipette tips. 4. Clean test tubes of dimensions 75 mm into 12 mm for clotting tests and test tube rack. 5. Thromboplastin or the PT reagent. 6. Control. This is the control for the liquiplastin reagent used in this demonstration. As is evident on the literature, control values are between 11 to 17 seconds and the target value is 14. 7. Patient citrated plasma specimens. Procedure. 1. Reconstitute the tissue thromboplastin according to the instructions. Ready-to-use reagents are also available in the market. Label the thromboplastin with date and initials.
This thromboplastin reagent is stable for 7 days after reconstitution or as written on the package insert.
Allow to sit for 10 to 15 minutes, then invert gently several times. Mix the reagent well prior to pipetting at every step in this procedure. 2. Take required amount of thromboplastin reagent into a 12 into 75 mm test tube and place in a 37 degrees Celsius incubator. 3. Pipette 100 microliters or 0.1 ml of control. 4. Allow at least 1 minute for the control to reach 37 degrees Celsius. 5. Pipette 200 microliters or 0.2 ml of PT reagent into the tube containing the control. Now, why do we add twice the amount of thromboplastin? The answer is, most thromboplastins come pre-mixed with CaCl2. In case CaCl2 is provided separately, follow the instructions of the manufacturer. 6. Start the stopwatch simultaneously. 7. Mix the tubes and leave in the water bath for a minimum of 7 to 8 seconds. Then, remove, wipe the exteriors, tilt back and forth gently until a visible clot is formed. As the clot forms, the mixture will gelatinize and may turn cloudy. As long as the clot is not formed, the plasma is clear and flows along the sides of the test tubes. As the clotting starts, the plasma turns turbid and the movement stops. This is why we employ the tilt tube method, as the tilting enables us to see the flow along the sides. 8. Stop the stopwatch immediately when the clot begins to form and record the time in seconds. Carry out one significant figure past the decimal point. For example, if your result is 12.23 seconds, report as 12.2 seconds. 9. In our example, the control result is 15 seconds. 10. Similarly, run the test sample. Always run each sample in duplicate whenever you run samples manually to rule out errors. For all duplicate runs, always calculate the percentage difference between the two readings. A percentage difference of more than 10 is unacceptable and that sample should be retested. The test results for the duplicate sample run are 16 seconds and 17 seconds. The average of the two readings give the final value. The normal range for PT is 10 to 13 seconds. It has to be established by each lab by MNPT. Document the results immediately. The documentation log should contain the following information: PT methodology, reagent name and lot number, ISI, MNPT and lab range values, date, name and ID of the patient, patient readings, mean and INR value. 11.
If the result is more than 30 seconds and INR is more than 2, inform it, as this could be a critical value. For several therapeutic reasons of anticoagulation, INR is maintained at a high level. For example, Normal INR is less than 1.2.
Expected INR in oral anticoagulant therapy for prophylaxis for recurrent DVT is 2 to 3. Expected INR in oral anticoagulant therapy for recurrent MI is between 2.5 to 3.5. Expected INR in anticoagulant therapy for heart valve replacement is user specific. Thus, relevant patient history is very important before reporting the PT. APTT, activated partial thromboplastin time, is used to evaluate coagulation abnormalities in the intrinsic pathway and also to detect severe functional deficiencies in factors 2, 5, 10, or fibrinogen. Specimen collection. It is similar to specimen collection for PT. The materials required: 1. 12 by 75 test tube. 2. Pipettes 100 microliters. 3. Pipette tips. 4. Calcium chloride reagent 0.025 m. 5. Partial thromboplastin consists of phospholipids and a contact activator. 6. Water bath, incubator or heat block at 37 degrees Celsius. 7. Test tube rack. 8. Wipes or gauze. 9. Stopwatch. 10. Controls. In our demonstration, the range of controls is defined between 35 to 53 seconds. 11. Patient's citrated plasma specimen. Once the reagents and controls are reconstituted, write the date, time, the expiration date, time and technology's initial on the bottle. Procedure. 1. Pre-warm a sufficient quantity of calcium chloride reagent to 37 degrees Celsius for the number of tests to be performed. 2. Pipette 100 microliters or 0.1 ml of control into a labeled test tube. 3. Into the test tube, add 100 microliters or 0.1 ml of pre-warmed partial thromboplastin reagent. 4. Incubate the control and the partial thromboplastin mixture at 37 degrees Celsius for 3 minutes. 5. Add 100 microliters or 0.1 ml of calcium chloride into the control and the partial thromboplastin mixture and start the stopwatch immediately. 6. Mix the tube once immediately after adding the calcium reagent. Allow the tube to remain in the water bath approximately 20 seconds, mixing occasionally. 7. Start observation after 20 seconds. Deftly removing and re-immersing the tube from the water bath. Wipe off the outside of the tube. Gently tilt the tube back and forth until a visible clot forms. 8. Stop the stopwatch immediately and record the time in seconds. Carry out one significant figure past the decimal point. For example, if your result is 30.31, report as 30.3 seconds. In our observation, the time recorded is 40 seconds. 9. Similarly, run the test sample in duplicate to rule out errors. The readings are 39 seconds for tube 1 and 41 seconds for tube 2. The average of the two gives us the final value of APTT. The normal range for APTT in our demonstration is 22 to 35 seconds according to the kit insert. However, all labs should establish their own normal ranges by analyzing 20 normal samples and finding the mean. Using a coagulation analyzer for PT and APTT. Coagulation analyzers are either fully automated systems or semi-automated systems. In semi-automated system, most of the functions are still manual. For example, pre-warming, pipetting, etc. All what the equipment does is incubation and clot detection. Also, coagulation analyzers are of multiple methodologies. We are going to show a semi-automatic photo-optical equipment where the clot formation is detected using a laser LED optic.
The following points are crucial to coagulation analyzers: the calibration curve, temperature setting mechanisms, optics and mechanics, and the timer.
These should be understood for their functions and checked as per the manufacturer's instructions. Appropriate preventive maintenance should be undertaken to keep these measurement mechanisms at the optimum. A manual method is more under control than a semi-automated technique unless you can check out the above. Blindly following procedural steps may result in wrong results if the temperature, optics, and timer are inadequately maintained. In this equipment, calibration is done for a normal of 30 seconds for APTT and calibration for PT is done as a default for ISI equal to 1.10. Temperature adjustment is done for 37 degrees Celsius. Optics are also adjusted to a high and low range with limits for amplification. Whenever the PT lot changes, the MNPT and the ISI value changes and the equipment settings should be readjusted. Procedural steps for this equipment is as follows. Warm up the instrument. It takes about 5 minutes for the instrument to equilibrate to 37 degrees Celsius. Different equipment will have their own specific instructions for use. Those have to be strictly followed. The test procedure for PT: run one test sample in duplication and calculate the percentage difference between the two readings. A percentage difference of more than 10 is unacceptable and that sample should be retested. Some machines can be programmed for duplicate testing. If your machine does not have this feature, run the same sample twice. Clotting method. Pipette 25 microliter plasma to cuvette. Pre-warm the plasma for 60 seconds. Press the timer 1 key to start the stopwatch 1. Transfer the cuvette to measuring position. Add 50 microliters pre-warmed and stirred thromboplastin reagent. The test will start automatically on addition of the start reagent. The test is displayed in seconds. Press the corresponding unit key for conversion of the results. The PT and INR results in our demonstration are 20.9 seconds and 1.70 respectively for tube 1 and 20.7 seconds and 1.68 respectively for tube 2. Test procedure for APTT. 1. Pipette 25 microliters plasma into the cuvette. 2. Add 25 microliters APTT to plasma. 3. Incubate exactly for 5 minutes or 3 minutes for ellagic acid-based APTT reagents. 4. Transfer the cuvette to measuring position. 5. Activate the optic. Press key optic. 6. Add 25 microliters pre-warmed calcium chloride and simultaneously start the optic. 7. The instrument will read for a maximum of 300 seconds. 8. The result is displayed in seconds. Sources of error in coagulation tests. 1. Associated with specimen. Inappropriate ratio of anticoagulant to blood. Clotted, hemolyzed or lipemic samples. Poor centrifugation resulting in high platelets greater than 10,000 platelets per microliter. Delay in testing or processing. Inappropriate storage.
Associated with reagents: incorrect preparation of reagents, failure to properly store reagents, use of reagents beyond reconstituted stability time or expiration date, contaminated reagents. Associated with procedure: incorrect temperature, incorrect incubation times. Increased incubation time is equal to decreased coagulation time. More than 5 minutes heating will result in the loss of heat labile factor 5. Incorrect volumes of samples, reagents, or both.